So we're being asked to write a polynomial with a specific degree and with specific zeros, and we do have a couple words in here you may not know, one of which is multiplicity, and the other thing I do want to mention is if you ever have a polynomial with real coefficients and it has an imaginary root, then the complex conjugate also has to be a root. And the complex conjugate is basically the same numbers, but whatever symbol was between the one you know about, the opposite symbol is going to be between these. So since this is 4 minus 2i, 4 plus 2i also has to be a root. So it's always the exact same numbers, but one will be plus and one will be minus. Nothing about the 4 changes. And what does this multiplicity mean? That means that whatever factor was created to make this, that factor shows up 2 times. So what happens is, with that x minus 3, if that's a 0, then I know x plus 3 is a factor, and because the multiplicity is 2, I'll put a 2 on this. And then I also know that because this is a 0, check this out. Basically, what do we do to get this? We took x and we subtracted the 0 to get that value. That's one way to look at this. We'll do the same type of thing with this. If this is a 0, then a factor would be x take away whatever that 0 happens to be. So we'll put that in parentheses. And then because the complex conjugate also is going to be a 0, we'll have x minus that other 0. And this might look a little bit familiar if you look at the previous example. In both cases it's x and all the numbers are the same, but the signs are a little bit different. So let's go ahead and multiply this thing out. I'm going to take care of this monster first. And using the patterns we talked about in example 2, first step really is to rearrange this so that it's x minus 4 plus 2i, and then x minus 4 minus 2i. And you might pause and look at where that's coming from, but basically what's happening is this negative sign is distributing, and then I'm regrouping the x minus 4's together. This minus sign is distributing, and I'm grouping those x minus 4's together. Going onward from this, I know that it's the exact same thing here, x minus 4 twice. It's a 2i and a 2i twice, plus or minus. So I can use that formula that if I have two things that are multiplied together that are identical but the signs are different, it's the first thing squared minus the second thing squared. So that'll give me x minus 4 quantity squared minus 2i squared. This I know would become a negative 4, and there's a negative up in front of here, so it becomes a positive 4. I'll write all this stuff out though. 2i squared is negative 4, and there's another minus sign, so I get a plus 4. And then this, I'm going to leave this alone for right now. And there's a pattern for this that I know as well, which is that I can take the first thing squared, the last thing squared, multiply those together and double it, and then that plus 4 follows. Now if you don't like that shortcut, then off on the side you're going to want to go, I'll go over here, you want to take x minus 4 times x minus 4, x times these both, negative 4 times these both, and you'll see you get this back again anyway. And then these like terms combine. So we end up with x squared minus 8x plus 20. So all that stuff is just to take care of the fact that this was a 0. A lot of work there. Now we still have this to deal with. So if I'm dealing with that, well, I can use that pattern at least. If it's x plus 3 squared, I can use that pattern off the bat and just take the first thing squared, which is x squared, the last thing squared, which is 9, multiply these two things together and double it, positive 6x. And now last but not least, we're going to multiply this whole thing out. But I'm going to take a pause on this video, and in the next video multiply those two things together so I can give myself some clean space to work in. It's just using those patterns and getting comfortable with them, so just if you can get through all that, you're going to be okay. It's one of these things that once it clicks, it's not so bad, but it might take a little while for this one to click. So just, as usual, be patient with yourself, and I'm sure you'll get it.